This will be for the con exercise, period of sinusoidal functions from equation. All right, so just briefly, I want to look at the graph of y equals sine of x. All right, and if you look at this graph here, if we go through one cycle or one period, let's start here at the origin, and we go through the cycle through the max, the minimum, and back to where we started at the midline. All right, so this distance right here is the period. Okay, and we can see for a normal sine function, the period goes from 0 to 2 pi. Okay, so if we subtract 2 pi minus 0, the period is basically 2 pi. All right, now if you remember from a previous exercise, when you multiply x by a constant term, it's either going to compress the graph or stretch the graph. All right, and just as a quick example, let's say instead of y equals the sine of x, we did y equals the sine of 2x. Now, if you recall, when you multiply x by a number that's greater than 1, it actually compresses the graph from left to right. It compresses it by a factor of 2. So instead of taking 2 pi, a distance of 2 pi to go through the whole period, it actually speeds up by a factor of 2. So this max here will now be at, instead of pi over 2, it'll be right here. And this midline here, instead of being at pi, it's going to be at pi over 2. Okay, so the graph cycles more quickly. It goes here, and then here, and then the minimum is going to be here, and the midline, it's going to return like that. So let me do this in a different color real quick. All right, so the new graph, y equals sine of 2x, it cycles more quickly than the original. It cycles twice as fast. So the period is now from this point to this point, and instead of 2 pi, the new period is just going to be pi, because it cycled twice as fast. Okay, the same thing would be true, or the opposite would be true if you did, say, the sine of 1/2 x. Instead of being twice as fast, it would be more stretched out from left to right, and it would actually cycle more slowly. Okay, so as a result, since the original cycles at, the original period is 2 pi, I'll show you the formula. So we're assuming the equation is in this form, okay? And we are just worried about this number right here, the number that's multiplied by x. And what they're telling us is the period of a sinusoid of this form is equal to 2 pi divided by the absolute value of b, okay? Period is a distance, and distances are always positive, so that's why it's absolute value of b. So if you have the equation in this form, you just look at the number that's multiplied by x, and you do 2 pi divided by the absolute value of that number, and that will give you the period, okay? This right here just affects the amplitude. This right here shifts it left, right. This right here shifts it up, down. So we do not have to worry about those other terms. We are just looking at this right here. In fact, just the constant that's multiplied by x. So we're looking at 2 pi over b. All right, what is the period of the function given exact value? All right, the period we said is just 2 pi over b. And really it's the absolute value of b. All right, so b is the number that is times x, so that's just going to be 2 pi divided by 7. Okay, that's it. And that makes sense. Since x was multiplied by 7, instead of the sine wave going slowly, it's going to go 7 times as fast. So that period is going to get shorter. And as you can see, 2 pi over 7 is less than the original period of 2 pi. So you do 2, click the pi, slash 7. 2 pi over 7. All right, what is the period of the function? All right, so the period is just going to be 2 pi over the absolute value of b. And b is the number right here. So it's just going to be 2 pi divided by 4. And that is just going to be 1/2 pi, or 1 pi over 2. Or you can just say pi over 2. All right, so click pi, slash 2. 1 pi in the numerator is the same as pi, and it's divided by 2. So we're going to go over graphs later, but cosine and sine, the period is the same. The original period is 2 pi. So the formula for the period is the same for the cosine and the sine. Okay, it's just going to be 2 pi over the absolute value of b. And b is the number that is multiplied by x. Okay, so here we have 5 pi multiplied by the x. So it's going to be 2 pi divided by 5 pi. All right, and of course the pi's cancel. And you're just left with 2 over 5, or 2/5. 2/5. So just briefly, the equation is in this form. We had a cosine this time instead of sine, but the formula is still the same. All right, last one. I was hoping to get one with a fraction, but anyhow, same formula, 2 pi over the absolute value of b. So we have 2 pi, and b is the number that's multiplied by x, that is both -4 and pi. Okay, so it's the absolute value of -4 pi. All right, so we have 2 pi. Absolute value of -4 pi is just 4 pi. Okay, I realize you can do that in one step. I just wanted to show you. Make sure you take the absolute value. Pi over pi is gone. 2 over 4 is 1/2. So it's just 1/2. All right, if you happen to get one with a fraction, just remember to use keep, change, flip. You keep the numerator, you change division to multiplication, and you flip or take the reciprocal of the denominator. That's if this number happens to be a fraction.